Hello again. So today we'll be going through 1995 or 1991 AB5. Before I do, I want to go back over even and odd functions. So an even function is a function that's symmetric to the y-axis. So if I was going to draw a line like this red line that I've drawn here, my y value on one side should be equal to the y value on the opposite side, because I'm symmetric to the y-axis. Vivian, can you give me an example of an even function?
Um, yes, I'm going to give you y is equal to x squared.
Y is equal to, say again?
X squared.
X squared. Okay.
X squared.
So y is equal to x squared, which should be a function that looks something like this. So y equals x squared. Um, my right side of my graph, um, if I was going to flip it, so let me flip it really quick. If I flip this graph, then my right side of the graph will look the same as the uh, left side of the graph. So if I had this as a piece of paper and folded it along the y-axis, then this would look like the same function, right? Um,
Mm.
Mathematically, I could say this. F of x is equal to f of negative x, which just means all of my y values on one side are equal to my y values on the opposite side. Again, looks something like this. If I was going to draw a straight line here, it's a massive straight line. If I was going to draw a straight line here, my y value on one side of the graph is equal to the y value on the opposite side of the graph that this line is passing through. Okay, odd functions are a little bit trickier. The way I like to think of odd functions are as rotations. So if I rotated the right side of this graph 180 degrees, I would get the left side of the graph. So that would look something like this. If I take this right side of the graph in red, and I rotate it 180 degrees, then I get an image that looks like the left side of the graph, right? Um, you could also think of it as if we were both sitting at the same desk and had this sheet of paper between us, one of us could flip the sheet of paper 180 degrees, and the graph that we see would look just like the original. So if we keep flipping this, the graph looks the same. Okay, so that's an odd function. Odd functions, get this back in. Odd functions mathematically, we could say are symmetric about the origin. Um, let me write that down really quick. So odd functions are symmetric about the origin, which means we can flip the paper 180 degrees and look at the same shape. I could also say f of negative x is equal to negative f of x if you wanted to test and see is a function odd. Vivian, can you give me an example of an odd function?
Okay, so I can say y is equal to x.
Y equals x, which I happen to have here. So y equals x is symmetric because if I rotated this entire graph 180 degrees, I would end up with the same shape. So if I do that, if I rotate this graph 180 degrees, it still looks like the graph of y equals x. Um, do that one more time. This is the graph y equals x. It is symmetric about the origin because if I rotate this graph 180 degrees, wah, it still looks like y is equal to x. Okay, so that's even functions and odd functions. So I'm going to take that and we'll take a look at our question from 1991. So Vivian, I should have sent this to you in the chat so you can see the table if you need to. You can download it off course sites if you can't see the video. So I've
Alright.
got f is a function that is even, which means we are symmetric. Everything that happens on the right side of the y-axis is the same thing that happens on the left side of the y-axis. On the interval from negative 3 to 3. The function f and its derivatives have the properties in the table below. So I'm given this table that has all of my values from 0 to 3. It does not have any of the values from negative 3 to 0, even though our interval is from negative 3 to 3. So our interval includes all of those values that are not on the table. Okay, the first question asks, find the x-coordinate of every point where f attains an absolute maximum or absolute minimum value. For every x-coordinate you give, tell me whether it's an absolute maximum or absolute minimum. So basically, just give us the absolute maximums and minimums. Vivian, what do I have to do in order to find an absolute maximum value?
To find the absolute maximum value, we need to find out the change of the slope from from positive to negative.
Okay. I'm
And
going to reword
for
that just a little
everything
bit because change
that,
in slope is really your second derivative, but we're looking at our first derivative, and we want to know, does the first derivative change at that point? From a negative first derivative to a positive first derivative. That would tell us, do I have an absolute minimum? If I'm looking for an absolute maximum, I would be looking for the opposite. So I'd look for a change from a positive slope to a negative slope about that point. Okay, so the first thing we need to do is derive this function. So I've got our derivative in the table here. Um, are there any points where that slope changes from a positive slope to a negative slope?
okay, from positive to negative, no, I cannot find it.
Right, okay, so there are
No.
no points about which f prime of x changes from positive to negative, which means there are no relative maximums. Okay, what other points do I have to test if I'm looking for absolute maximums? So not just relative maximums, but also what?
The minimum.
And okay, I don't need to test the minimums if I'm looking for absolute maximums. We just said there's no points where the slope changes from positive to negative. So does that mean there's no absolute maximum, or does that mean we still have more points to test?
Okay,
What other
we
points?
need to find the.
Okay, I think you just said it, but we need to find the start point and end point as well and test those. So to find the absolute
Okay.
maximum, we also need to test the bounds of our interval to see which y value is the largest. Okay, looking at the y values and start point and end point. So I've got x equals 0 and x equals 3. Which point is going to be largest?
Um, 0. If
Okay,
it is 0, you have 1.
the y value at x equals 0 is larger than the y value at x equals 3. Therefore, which point is the absolute maximum?
It's 1. 0.
At x
When your x is
equals,
0, your y.
right, at x equals 0. Okay, and they asked us for the x coordinate, so I'm going to leave it just like that. Now, our graph is symmetric, which means whatever happens to the right side of the graph also happens to the left side of the graph. Um, do we need to worry about that for the absolute maximum or not?
Um, I don't think so. We only have to find the.
Okay, we said the absolute maximum is going to be at x equals 0. Um, the symmetric point to x equals 0 about the y-axis is still x equals 0, right? So we ended up at the same point. So there's only one absolute maximum for this graph, if this graph is symmetric from negative 3 to 3. Okay, so then we also need to look for absolute minimum. So to find the absolute minimum, our slope needs to change from what to what about that point?
From positive to negative.
Positive and negative would mean we're changing from increasing to decreasing, so that would tell me a relative maximum. If I want a relative minimum, what needs to happen?
Okay, so from negative to positive.
Right, f prime of x changes from negative to positive um, at x equals what?
Okay, if x is equal to 2,
If x equals 2. Um, therefore,
f
x equals 2 is a relative minimum.
minimum.
Okay. Now, because we are symmetric, we are an even function. If x equals 2 is a relative minimum, what's another point that's a relative minimum?
I can have negative.
Negative 2, perfect. Um, as f of x is an even function and is symmetric about the y-axis, if x equals 2 is a relative minimum, then x equals negative 2 is also a relative minimum. Okay, that's not all for absolute minimum though. I also need to test the start point and the end point. So my start point has a y value of 1. My minimum at 2, relative minimum, had a y value of -1, so I know that the relative minimum is less than my start point. But what about the end point? Because it just says negative, so how do I know that that negative value is going to be above or below -1?
Um, the above value is above -1 because um, because the value of x greater than 2 is positive.
Okay, the value of the slope is positive. So you're right. We know that our function is increasing. We are told that f prime of x is positive from 2 to 3, from, say, x equals 2 to x equals 3. Therefore, x equals 3 must be above x equals 2. I'll say the y value. Therefore, the y value at x equals 3 must be above the y value at x equals 2. X equals 2. Therefore, x equals 2 is the absolute minimum. And what else do we need?
I need to pick the other points.
Okay, the other point, because this is even and symmetric, so if x equals 2 is an absolute minimum, what other point is an absolute minimum?
So -2.
Right. As f of x is an even function and therefore symmetric about the y-axis, if x equals 2 is an absolute minimum, then x equals -2 is also an absolute minimum. Okay, so that's it for part 1. For part 2, I need to find any points of inflection on our graph of f. How do I find a point of inflection?
The point of inflection is you need to find the concavity using the second derivative. So once the concavity changes, that's what the point of inflection.
Okay, at what point does the concavity change around?
It changes to where your 1 is 0. So
Uh,
it changes from when your x when your x is 1.
okay, perfect. When x is 1, my concavity changes from positive to negative. Are there any other points of inflection?
-1.
Awesome. Okay, so f prime prime of x changes from positive to negative at x equals 1. Therefore, x equals 1 is a point of inflection. Since f of x is an even function, if x equals 1 is a point of inflection, then x equals -1 is also a point of inflection. There are no other points on 0 to 3 um, where the concavity changes. Um, so the rest of these, at x equals 2, I go from negative to negative, which is not a change. At x equals 0, I go from positive to positive, actually, because this interval from 0 to 1 would be symmetric, would also be the interval from -1 to 0. So I would change from positive to positive, and that's not a point of inflection either. Okay, so the only points of inflection are at, rewrite the answer, points of inflection at x equals -1 and x equals 1. Alright, the last thing we need to do is graph this. So I'm going to take a picture of everything and we'll graph together. Okay. So we're told to sketch the graph below. Um, so I'm going to graph all of the points that we know for sure first. Um, so I know for sure that
So you
at
have x
x
is 0
equals
and
0, my y value is 1. What else do I know for sure?
when your x is 1, you have 0.
Okay.
If you have 2, you have negative 1.
I'm going to do these in another color, I think. Okay, and when x is 2, uh, you said y is negative 1, which we got from the table. So those are 2 points, 0, 1, 1, 0, and 2, negative 1. Now, because this is symmetric, I know 2 more points as well. So what are the other 2 points that
Okay,
I know?
we have negative 1 and 0. We have negative 2 and negative 1.
Perfect. So negative 2, 1, and negative 1, 0. I'm going to grab that same color. Okay. So then I'm going to graph, um, we'll graph a line through this that matches our data. Um, so we were told that from 0 to 1, I am decreasing concave up. So if I'm decreasing concave up from 0 to 1, my graph should look something like this, decreasing and then concave up. Um, and then from 1 to 2, I am decreasing concave down, decreasing and concave down. Oops, decreasing concave down. So something like that. So if I put that both together, my graph should look something like this. Okay, I am, uh-oh, hold on. Didn't do that right, actually. I did the opposite. Try again. There we go. I am decreasing in concave up first, and then I'm decreasing concave down after that. Okay, so my graph should look just like that. And it's symmetric, so I've got to do the same thing on the opposite side. So that'll look something like this if I'm symmetric. Okay, and then I'm also told that from 2 to 3, I am increasing and concave down, but then I end up at a negative value, so I don't make it to 0. So increasing, concave down, and don't make it to 0. So it's something like this. And the same thing on the opposite side. Okay, so just to check now that we have the graph in front of us, with our graph, what is our absolute maximum point?
Alright, the absolute maximum point is where x is equal to 0 and your y is 1. That's our absolute maximum.
Okay, reduce the size of this just a little bit. We have an absolute maximum at x equals 0, y equals 1. Where do I have points of inflection?
So the point, this is where I think I need to change this, so that falls between 1 and negative 1.
Okay, that falls at 1 and negative 1. So these are points, not ranges. Points of inflection. I'm going to write point, and we'll just write it twice. Point of inflection, point of inflection. So we got points of inflection at x equals 1 and x equals negative 1. And then we have absolute minimums where?
Yeah. Absolute minimum falls when x is equal to negative 2 and positive 2.
Okay, absolute minimums at x equals negative 2 and x equals positive 2. Perfect. So that gives us our graph with all of our information. So let me flatten this so everything's together, and we'll have everything we need. Okay. Shorten this just a little bit. I've got a little bit of you in the corner. All right. Any questions on what we did?
No.
Awesome. Well, thank you very much.